Chapter 5, Lesson 3 of Advanced Algebra, we're going to look at, now that we know what vertex form is, how can we use it to help us create our graphs. And actually, vertex form is going to make it very easy for us to sketch these graphs, because rather than going through the whole opposite of b over 2a to get the x value and then substituting that in to get the y value, in vertex form, we already know where the vertex is, so we just simply do a shift right or left. So 4 steps to doing this is we'll shift the vertex using the horizontal and vertical shift. So we'll be able to locate the axis of symmetry. That's going to be the horizontal shift, or the x value of the vertex, and also give us the vertex. We'll then be able to graph the y-intercept if we can. Again, remember, we simply substitute in 0, because that's what the x value is on the y-intercept. And then once we have that, we can graph the corresponding points using the symmetry of the graph. We then only need one other point, so again we can select our own x value, substitute it into the expression to get the y value, and then graph its corresponding point, giving us nice 5 points that we can then use to connect with a smooth curve. The only thing we have to remember then, or make sure we remember, is that that negative sign in front is going to make that open downward. So let me do an example for you, and then I'll do another example video, and you can watch as many of those as you need in order to help you out. So let's go ahead and take an example. So here, let's graph this. It's already in vertex form. So the negative sign tells me it's going to open upside down. The 4 is going to be a stretch, and remember, a stretch is going to make that U more narrow. And then the horizontal shift here is to the left 8, and the vertical shift is down 6. So using that information, I can sketch this very quickly. So it's a vertical shift. Well, let me put my scale on here. So this is going to be x. Well, you can't see yellow on yellow, so let me put black on yellow. That would be better. So here's an x and a y, and I can use my scale 2 and 4 and 2 and 4. So I know that it's a horizontal shift is inside here. It's going to be the opposite, so it's going to be shifted to the left 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be my axis of symmetry. I know that the vertex is now down 6. So down 6 on this line here. So 1, 2, 3, 4, 5, 6. So that's going to be about right here. So the vertex is going to be -8. The shift left, and the shift down -6. The axis of symmetry is going to be at x equals -8. Okay, and again I need to label these. And now it opens down, and so the y-intercept is going to be if I substituted in 0, but because I'm so far away from the y-axis, it's going to be way down here, so I'm not going to be able to do that. So I'm just going to choose another x value that's close to my axis of symmetry, graph its corresponding point, and then graph it from there. So again, I can choose an x value. I'm going to choose -7 because that's close, and I'm just going to substitute in that -7 into the expression and then simplify it to get my y value. So -4 times -7 plus 8 is 1. 1 squared is 1 minus 6. So -4 minus 6 is -10. So at -7, the y-coordinate is at -10. So down here, I'm all the way down here at -10, so that's going to be about right here. It's symmetrical, so I have another point over here. So I'm going to, whoops, that's not going to be a very good picture. I'm going to try to draw this with a nice graph like that. And then again, I want to label the graph. So y equals -4 x minus 8 squared minus 6. So that would be the graph using the vertex form. And again, you can see I can sketch it very quickly by using the vertex form. Okay, I'm going to do another number of examples. Again, as always, you watch as many as you need to help you figure out how to do it, and then you can stop the video anytime you like. My next example here, I have -x minus 1 squared plus 4. So again, I'm going to put my scale on my axes. Okay. And again, I'm going to use what I know about vertex form to help me graph this very quickly. The negative sign tells me that it's going to open down. This is a shift to the right 1, so my axis of symmetry is going to be at 1. And then the vertical shift is up 4, so my vertex is up 4 along this axis. So it opens down, so I'm going to put my label up here. The y-intercept is going to be when I substitute in 0. So if I put in 0 for my x value and solve this, that's going to give me my y-intercept. So 0 minus 1 is negative 1 squared. Negative 1 squared is 1, but the negative sign is negative 1 plus 4. So that's going to be a 3. So my y-intercept is going to be at 0, 3. So right here is my y-intercept. And then because it's symmetrical, I have a corresponding point over here. Then I need one more point to help me graph. I can't use 2 because that's already taken care of by this corresponding point, so I'm going to choose the value 3. And again, I simply substitute in the x value and simplify it in order to find its corresponding y value. So negative 3 minus 1 is 2. 2 squared is 4 plus 4. So this is negative 4 plus 4. So this is 0. So when I choose 3 for my x value, the y value is 0. And I don't think that that's going to be, oh yeah, 3, 0, right out here. And then again, because it's symmetrical, I have a corresponding point here. So now I have my points where I can go ahead and draw my nice smooth curve. And then again, we'll extend that down. These kind of go out and down at the same time. And then again, I want to make sure I have everything labeled. And my axis of symmetry is at x equals 1. Okay, so those would be all the points that I would need on my graph. And if I check that out, you see I'm pretty close. All right. Again, I'm going to do a few more examples. You watch as many as you need in order to help you tackle your homework. All right, my next example here, again, we're in vertex form, so we can go ahead and label our axis here. So I notice a negative sign, so again, I have a parabola that's going to open down. The 3 is a stretch, so it's going to be kind of narrow. And again, I can use the horizontal shifts to get my vertex very quickly. So a positive 7 means I'm shifted to the left 7. So 1, 2, 3, 4, 5, 6, 7. So my axis of symmetry is at x equals negative 7. The vertex is shifted down 8 along there, so that's going to be about right here. So that is at negative 7, negative 8. And again, I'm really far away from the y-axis, so finding the y-intercept isn't going to be of much use here because it's not going to fit my scale. So I just need to pick another number close to the axis of symmetry that will allow me to get another point on each side. So I'm going to choose negative 6 and substitute it into the expression and then simplify it to get my corresponding y value. So negative 3, let's see, this is going to be 1 squared. So this is going to be negative 3 minus 8, which is negative 11. So when I choose negative 6, I'm down to negative 11, which even that is a little bit off my scale here, so I'm just going to have to kind of estimate it. It's symmetrical, so I need to put one on each side, and then I can go ahead and sketch that graph way out here. Again, if I was doing this on a homework piece of paper, I would probably want to make my scale a little bit bigger in order to accommodate my graph, but because I'm using the same scale on here to see it, I need to use that. So, oh, actually on that one I did use a different scale in order to accommodate that, so I could have done that. But you see my vertex is it's on the axis of symmetry, but again, this is a scale of 20, so that's why it looks a little bit different. But it's actually the same. So let's go ahead and do another example. Again, you watch until you think you have it, and then you can tackle your homework. Okay, our next example, again, we're in vertex form, so I can go ahead and use my shifts. And I want to go ahead and put my scale on my axes. The 2 is a stretch, so it's going to be a narrower parabola than the parent. And this is a negative 2, so that means it's a shift to the right 2. So my axis of symmetry is at x equals 2, so I'll write that on there. The vertex is along this axis, and it's shifted up 5. So my vertex is going to be about right here. It's positive, so it opens up, so I can go ahead and label my vertex there. The y-intercept, I'm kind of close. I might be able to get the y-intercept here, so let's try that. That's by, again, an x value of 0 is my y-intercept. So this is negative 2 squared, which is 4. So this is 8 plus 5. So my axis of symmetry, I'm sorry, my y-intercept is actually at 13, which is up off my scale. But I want to kind of keep that in mind, so when I draw my parabola, I make sure that I don't cross the y-axis before this point up here is up 13. So I still need to kind of know where that is, so I don't draw this out here crossing down here where it actually doesn't cross. So it is symmetrical, so I'm 2 away on this side, so 2 away on this side. So I do need another point. I'll pick one close to the y, to my axis of symmetry, so I'm going to choose an x value of 1, and we'll substitute that in and see what we get when we choose an x value of 1. So 2 times 1 minus 2 squared plus 5. So this is 2, 1 squared, negative 1 squared is 1 plus 5. So that's going to be 7. So when I choose 1, I have a y value of 7. So this is a 4, 5, 6, 7. So 1, 7, I'm going to be about right there. And again, because it's symmetrical, I have a point over here. Now because I found my y-intercept, I'm not going to be tempted to go out here and cross here because I know it doesn't cross till up here. So I can keep that. That's not very good. I can do better than that, I think. Let me try that again. So my parabola should look something like that. And then again, I want to put my label on here. And that should be the graph of my parabola. So again, I hope you see it's a little bit quicker using vertex form than it is in standard form, because the vertex is already calculated for us, so we don't have to go through all that when we're in vertex form. So it's much easier. Okay, so one final example, and then you can tackle your homework. So x minus 1 squared plus 2. It's a positive in front here, so I know it opens up. There is no number in front, so it's looked like the parent parabola. The shift is to the right 1, so my axis of symmetry is going to be here at x equals 1. And my vertex is a shift up the axis of symmetry 2. Oh, well, without a scale, we really don't know where that is, so we should probably put our scale on here. So my vertex is at here at 1, 2. My y-intercept I can get by substituting in y for x. So this is going to be 1 plus 2, which is 3. So it's going to cross the y-axis at 3. And again, it's symmetrical, so I'm going to be here. And again, I need to choose another x value. I can't use 2 because I already know what the y value is. So I'll go out here and use 3. Substitute it into our expression to find the corresponding y value. So when I choose an x value of 3, I get 4 plus 2, which is 6. So an x value of 3 gives me a y value of 6. And again, it's symmetrical, so 2 this way, so 2 this way. And now I have my points that I need, and so I just need to connect those. Oh, come on. I can do better than that. Come on. Okay, that's not too bad. I kind of missed, but I think that's pretty close. So then again, we label. And we check, and we have our parabola, which is in pretty good shape. All right, so that's how you graph using vertex form. I hope that was helpful. In the next video, we're going to learn how to write equations now in vertex form, given 2 points or given standard form. So we're going to tackle all those in one video.